Hi, I'm Cassidy Phillips. I'm the Director of Customer Solutions for Switch.io, and we're talking about a joint demonstration with Bridge Technologies. So what CloudSwXtch does is we enable you to extend your multicast network into and through the cloud. We have the ability to take SRT, make it unicast or multicast, or we can take multicast and make it SRT. This means we can do all the things you expect in your multicast network in the cloud, including some of the visibility. What we do is we create a virtual overlay over the infrastructure that's in the data center. So we have virtual NICs, we have a virtual network switch, and we have what we refer to as our bridge. This is all software. It's all lightweight software that you just deploy on existing servers or machines in the cloud. This overlay allows that to just feel like an extension of your multicast network, meaning that these endpoints in the cloud can dynamically request any multicast that's available on-prem through the same address, the same behavior that they would have requested it as if they were on-prem. Say a multiviewer wants to get a camera from on-prem into a cloud multiviewer, it can send an IGMP join request the same way, and we know that it can be milliseconds. The combination of Bridge Technologies and Switch.io means that you have that extended network, and your Bridge Technologies endpoints can do all of the things that they normally do across that entire connected fabric. So I can use my VB440 to look at SMPTE 2110 that went through the cloud, both JPEG XS and uncompressed. I could use my VB220 to grab transport streams from anywhere in the cloud. And so you get the combination of that visibility, that performance of a multicast network in the cloud, as well as all of the media visibility that Bridge Technologies gives you. To prove this, and to prove that we're not doing anything special or proprietary like using a special converted compressed format to get in and out of the cloud or anything like that, we put a VB440 on-prem, and we connected to a cloud switch in the cloud, and we sent 2110 over a public internet connection, and then we actually just changed the multicast address so we could send it back, allowing the VB440 to lock to both the native from the camera multicast, as well as the return that had made the full loop back through the cloud. You can see here, the multicast address is different, but this is ST2110-22 JPEG XS at about 193, 196 Mbps. Both sides, same frame rate, same resolution. Nothing about this has been changed. And we're 1 to 2 frames of latency, even using the public internet to get up and down from the cloud. When someone has an express route or direct connect type of a connection, reserved bandwidth, then you could have milliseconds of latency back and forth, allowing this to feel like an extension of your own facility. This also means that things like NMOS would work for you. So you could use NMOS to talk to your Bridge Technologies scopes or any other NMOS-enabled endpoints you have, and it's going to be the same router panel that you use on-prem, talking all the way through the cloud and bringing things from the cloud back to ground or from the ground to the cloud. The other thing we can do is use that VB220 to look at your compressed streams, as I talked about earlier. The 220 also uses multicast when enabled. And so in this example, what we did is we have a relationship with Cinefilm's Tachyon Live for frame rate conversion. And we took the input and converted from 50 FPS to 5994 FPS. Now we want to prove this, and we want to see that the conversion functioned properly. So we actually go via multicast to a VB220 in the cloud, and we confirm, okay, the original was 50, and the converted is now 5994. And I can do that with any multicast stream in the cloud. So this really just breaks down the same narrative that I just explained as far as what we're doing in the system. This was actually a workflow that Bridge Technologies and Switch did not make up out of nowhere. This is something that is actually being used in projects. This is a basic why multicast in the cloud. Well, because I can do one-to-many via IGMP. It's a standards-based functionality. I don't have a proprietary transport or compression. I don't have to compress and recompress through my encoders. And I get that low latency performance that enables live production to be possible. Thank you for your time. Cassidy Phillips. Let us know if we can help you.